So there was a Greek philosopher who once said that there's only one constant in the universe, and that is change. And when he talked about the constant, I mean, he was not talking about a constant in mathematical terms like pi, for example, but more like state, constant state of change. And I believe it is so. I think the change is not only constant, but it's also increasing. It's happening faster and faster, like an exponential function. And it's much thanks to the digitalization that we see in the world. With AI technology, we have Internet of Things, big data, smartphones, and all that functions that augment us and make us more productive and more intelligent. Because of this change that is happening, Mälenergi have started a strategic journey where we look into how can we follow in the change that is happening. We're looking into value-creating business development, we're looking into value-creating product development, and we're looking into value-creating digitalization, where creating efficient energy systems is one of them. Automation is also another one, and also creating a resilient society through a city control room is a third one. The Smart Flow project is part of this creating efficient energy systems. So my name is Henrik Wickström, as I was called. I run orienteering. I'm also father of 2 lovely kids and a proud dad and a proud husband to a lovely wife. I'm also an Iron Man. Yeah. Okay. So, heating as a service. All this with the project Smarta Flöden started with actually an after-work session me and 2 colleagues had. We're sitting down having a beer and we're discussing, okay, what's the future of district heating? Is the future of district heating that we should sell consumption of energy? No, we don't really know. Then what is it? I mean, back then, it was 2 years ago, roughly. It was really hot that, okay, they assumed, I mean, it was a general assumption that every customer was a technological geek that wanted to analyze exactly what consumption patterns they had in order to make it more efficient. And we said, is it really so? And we thought, okay, let's assume it's not like that. The customers don't really care. Most of the customers don't really care. They just want comfort. They just want it wants to be warm and comfortable at home, especially when they are at home. So if it is like that, what do we need to do in order to make that possible, heating as a service? So that was the general idea, the start of, okay, what do we need to do in order to make this? Challenges we have in the district heating right now, it's a conflict based on what's the demand. Is it increasing or is it decreasing? Scientists say that it's decreasing, but a prognosis that is looking at actual outcomes says that it's increasing. So it's a little conflict here. We have heat pumps is one thing that is a major challenge or a threat to the district heating industry. Ultra-efficient homes combined to the heating pump. Ultra-efficient homes is homes that basically don't waste any energy at all. And we have less residual potential for conversion. The other thing is change customer requirements. Customers want to influence more. There's a lack of trust. They want more transparency. They want to know why it is like it is. Why do I have this? Why is the bill like it is? They question the environmentally friendliness of the product as well. And I think this is tightly bound to the lack of trust. They want more increase in transparency. They want extended content as well. They want more than just the consumption, paying for the consumption. The other one is tax on incineration of waste, which is, I don't understand the law at all. Don't really know what they want to achieve by adding tax to incinerating waste. Wouldn't it be better to have tax on, I don't know, for let's say emission, more emission from the burning of the fuel type. Anyway, another one is biofuels. It's starting to be a high-value commodity. I mean, in Sweden we have a lot of forests, we have a lot of biofuels. But what we see for the future, like 2030, is that wood will be a high-value commodity. You will start to make clothes, fabrics from wood. You will start making oil more from wood and so. So using biofuel wood for creating district heating will not be that economically good. I mean, you will have better things to use it for. So the general principle of creating district heating is it's quite simple. You boil water, you heat water in one system, that heats water in another system, that is the distribution, that heats water in the third place, which is the house. So what you do today, well, what the operators do today, they look at their own world. Okay, this is our situation. We produce water, we heat water, and as long as we do it in the best possible way, everything is good. The distribution looks at their part, making sure that, okay, the heat comes from, we can distribute the heat from the production to the end customer, and in that circle, everything is fine. And the consumption, and the customer looks at its own house and just makes sure that it's warm and cozy at home. And I mean, this is also what we question in this project. Why doesn't you look at the whole chain? Because everything is connected. So why don't you open it? So today, when you create district heating, you look a lot on the weather prognosis. It's the weather prognosis that help us create the prognosis of what to produce. How much water should we produce? What temperature should we produce? We look at some pressure points in the grid today, maybe 2 or 3 or something. And as long as the pressure is okay, we are fine, and we are confident that the heat reaches the end customer. But in truth, we don't really know what's happening in the grid. We also produce a little extra in order to be sure that the end customer gets the heat that they want. And this is very expensive, especially in January, where it's, I don't know, this winter was quite cold. I don't know the lowest peak, how much it was, but in Sweden we call it vargavinter. That's why you can see the wolf here. It's wolf winter, it should interpret it in English. And when you have that much cold, then it starts to be expensive. Because then you have to create these peaks, these peak productions. And that is when you have to start boilers that you generally don't want to use because they use oil. Because oil is the only boiler that can be used in that type of cold to create that extra heat. And that is expensive and it's not good for the environment. We also have an extremely large grid. We have 86,000 kilometers of district heating grid. We have 98% connectivity in Västerås, and we have around 15,000 households that is connected to the grid. And it takes a long time for the heating to reach the customer furthest away in the grid, up till 15 hours. So it's not like on and off production in district heating. So because of this complex and all this question and all the vision we had, we created the project Smarta Flöden. And it's a collaboration between Mälarenergi, RISE6 Västerås, Sigholm, Mälardalen University, ABB, and Evothings Labs. And it's funded by Vinnova and PIA. So what we're doing, and have been doing, of course, one of the first things that we needed to do was, okay, where do we do this? So we started to look at the platform, setting up a platform, defining which data should we be using, how frequent should we have the data in order to make what we want to do, how do we integrate all this data, how do we create the information model, how do we handle the anomalies that we can find in the data. They also did a master thesis on physical models from Mälardalen University. So in the project, we also discovered a new thing that we wasn't expecting from the first thing, physical models. That was really interesting because that can complement what we're doing in the project. We started working with user experience in order to make sure we do it for the right reason and that the end users really, we can solve their pains, the pain points they have in their daily work. We started developing machine learning algorithms on the historical data first. And we started to expand the physical models of in the district heating model network. We're starting to make simulations as well on the physical models. And we made a more robust setup in the platform in order to handle all this data. So what we're doing now, I have to look like that. So what we're doing now is we're starting to develop the machine learning models on the real-time data because it's the real-time data that's really interesting. I forgot to say back when I introduced the project, what we really want to do in the project is we want to make sure that how much and when should we produce in order to meet the customer demands. So we take into consideration every meteorological factors, the temperature and whatnot. We take into consideration the distribution time, which is really important because that's something that haven't been done before. And we also take into consideration how do the customers behave, how do they consume, when do they consume, and so forth. We're also making an adaptive network model. Since we got this physical model, the statistical model was the first. That was the first point that we wanted to do. We knew we wanted to do a physical model, statistical model. But then when we got the physical model, we started to think, okay, can we use these combined? Can we create a hybrid model? Because we know what is by the metering data from that we have out in the distribution, and by the statistical model, we know what is going to be. So with a physical model, we could figure out, okay, what should it be physically? So if we have a statistical model then it can coexist with the physical model to learn what is physically possible. So self-learn and make better prognosis in the future. And then we want to integrate this in the process. So what we do in the research project, we also want it to be used, of course. Okay, so what have we done? What lessons learned so far? The data, of course, it's one of the key things in this project. And we started to work with a big data platform. It was a lot of work with, as I said, integrating all the data. I mentioned the anomalies. Examples of anomalies that we had was, for example, one of our meters was supposedly in the middle of the Pacific Ocean. And obviously that's not right. Another thing that we found that was the biggest consumer in Västerås was a family home in central Västerås. It had, I'll see if I remember, it was 3 times as big as IKEA, for example, which was obviously also very completely wrong. And the reason for that was it was a decimal error from the meter, and that was corrected in the metering system that we use to bill, but in the collector meter system that was completely wrong. So We worked a lot with an analysis team in order to figure out, okay, what's right and what's wrong and so forth. What do we need to change something? How do we understand this? How can we understand this correctly for the future to create the models that we need to have? Of course, the machine learning. What model should we use? We're still working on that, trying to figure out which model to use. And also social behavior. Sounds very, it's not like we look at people, how they behave, but we can see, we saw that the consumption for the house, it's quite easy to predict. But exactly how people behave when they shower, when they use water from the tap and so forth, that's harder to predict because it's very variable. And the more you aggregate, the more houses you aggregate, the easier it gets to predict. Physical models, use them for validating. As I said, what should it be physically? And also the hybrid model. It will be very interesting to see what can we do with the hybrid models. The visualization, we've been working a lot with user experience, interviewing a lot of people in the process. What do you need? What's your pain points? In order to create these user-centric dashboards where we can present what we're doing and also expand with other functions as well. So that's what we're doing in the project. And to summarize it, as I said in the beginning, with this change, the Smart Flow project and the value-creating digitalization that we're working with, it's a lot of what's really the future for an energy company. Before, I mean, we've been producing electricity and heat and distributing it. And what we're seeing with everything that's happening in the digitalization, all the change that is happening, is it our part in the future as well? With the solar energy, micro consumers, what position should we take? What's our mission in the society, basically? So that's what I had to say today. Thank you.